Until last week, we mainly talked about the issues and the solutions that occurred during designing and constructing Taipei 101 related to its environment. This week, we will handle some special factors of Taipei 101 that occurs from its height. Vertical transportation. The first topic will be the transportation of concrete, and secondly, we will talk about the elevator that was the fastest in the world until 2014, and now the third fastest. Almost every building uses concrete as the main material. We are all aware of that. We can then also know that concrete is used in Taipei 101. The whole Taipei Tower all the way up to the 101st floor is made of this stuff. But how? How did concrete, the world's favorite construction material, ended up well over a quarter of a mile, 440 meters, straight up? A key to this is a special pump. Powerful piston pumps use vacuums and mega pressures to deliver concrete. Pumping requires technology since a pipe filled with concrete weighs over 13 tons. Pumping concrete is big business, and as buildings get higher, the technology to power it to the top gets more sophisticated. In the case of Taipei 101, a chain of interconnected pipes stretches to reach the high floors on the building. The floor sits near the base of the building, while the rooftop stands 101 floors above. During this process of concrete movement, it should be kept flowing by the super pump. One of the main jobs of the pump is to keep the construction alive through the use of 12-cylinder, 562 horsepower joint diesel engine.
This is the heart of the operation. Literally, it's the pump that keeps the construction alive. The moving parts in here made it possible to pump the concrete even to the highest floors.
A column of concrete must be kept flowing or the mix will separate, or even worse, set. A simple mechanism was used here. The engine operates two pistons. A simple vacuum pulls the liquid concrete in, and then the huge diesel engine generates hydraulic pressure to push it out. This mechanism was an idea from 300 years ago that just hundreds of times more pressure for a much weightier task. This is how they got concrete to the top. Then, how did people reach such height safely and quickly? This brings us to elevators in Taipei 101. The Yokohama Landmark Tower elevator was the fastest elevator in the world, moving at 715 meters per minute. Until the Taipei 101 elevator was introduced to renew the record significantly with an elevator speed of 1010 meters per minute. A powerful driving system with control system function is needed. So Toshiba, which built the Taipei 101 elevator, used the newly developed twin-winded permanent magnet synchronous as a traction machine. Thanks to this new traction machine, elevators receive 168 kilowatts of power on average. Compared to other elevators, you will find that it receives twice as much power as the ultra-high-speed elevator. However, due to this high speed, side effects such as vibration and noise also occur. In order to provide passengers with a comfortable ride, these two major obstacles had to be overcome. First, let's find out how Toshiba overcame the vibration. Toshiba aimed to keep the size of the elevator's vibration from peak to peak below 10 cm per square second, a figure that can be assumed as the optimal level for the lateral vibration of a car when running at 1010 meters per minute. Two techniques were used to reduce the vibration of elevators. The first is the active mass damper, which was mentioned a lot in the previous announcement. In short, when the sensor detects vibration, it moves in the opposite direction to control the vibration. Using this, the momentary vibration of the elevator was reduced by about 20%. Secondly, new roller guide reduced vibration. Minute deflection on a rail effect, the elevator's forcible displacement, and aerodynamic force. This caused lateral vibration of the car. Ends or distortion of the roller guide cause compulsory force to the car. The transference of force pressure can decrease to 25% up to 10 Hz and 65% at 20 Hz, compared with that of conventional elevator. Then, in the case of noise, let's find out how the effect on the elevator has been reduced. Toshiba reduced noise by applying aerodynamic design to the outside of the elevator. When elevator travels in a narrow shaft at high speed, wind noise occurs. Wind noise energy is equivalent to about 6 times the power of the running speed. Though it is generally negligible, wind noise becomes a factor at the great speed of 1010 meters per minute. Thus, Toshiba analyzed air pressure in the hoistway when the elevator was running. The aerodynamic performance of the capsule was analyzed, showing that the streamlined design reduced wind noise. The entrance section, in particular, has relatively loose sealing because of the opening and closing operation of the door panels. Thus, there is external noise in the car. For this reason, the top spoilers of the wedge configuration attached to both ends of the capsule were improved. By use of an aerodynamic capsule, Toshiba was able to reduce the noise level to the same as that of a conventional 600 meters per minute elevator. As the building goes high, the air pressure decreases. In Taipei 101, as the fast lift goes up and down, the air pressure in it goes down and up rapidly. It is okay when it goes up, which causes a decrease of pressure. The pressure in middle ear is naturally adjusted to the decreasing pressure. The problem happens when it goes down. The sudden growth of pressure makes your ear painful or unpleasant at least. So the whole lift is pressurized like aircraft. A zone is made as the door closes. Air pressure is slowly controlled while the lift is traveling. Although it is short that the surrounding air pressure changes, by preconditioning, the pressure changing rate is reduced. The ears stay comfortable. The governor means a controlling device used to keep the rotation speed of an elevator constant. In Taipei 101, the governor is simpler and more compact, but with enhanced performance stability. The brakes in the elevator in Taipei 101 are made of ceramic. Why? The reason is because an ordinary metal cannot stop operating in the elevator of Taipei 101. The high-speed elevator covers the 81st floor in 37 seconds, reaching as high as 1000 degrees Celsius. This may lead to a fire, so heat-resistant ceramic was needed to dissipate the heat. Also, the elevator can speed up to 60 km per hour, and for safety reasons, if abnormal acceleration is detected, the stabilizer will hold the guide rail and stop the elevator. The last thing I want to talk about is oil buffer. The oil buffer is a device for controlling the vibration of the elevator, which absorbs the shock hydraulically. In Taipei 101, the oil buffer is 10 meters long, allowing for the expansion of 3-stage telescopic hydraulic buffers to make the most of the space used, each of which is designed to withstand 11 tons of collisions. Through these processes, the operation of elevators in Taipei 101 was safer and faster. To summarize, we mainly talked about the vertical transportation applied in Taipei 101. Strong pumps to deliver the materials like concrete and the elevators to carry people along its height. Especially the elevator technology regarding speed, comfort, and safety. Next week, we will look through the overall issues of Taipei 101 and review some must-know solutions. Thank you.